Welcome to True Projects. In this video, we are going to explain about the project that is design and optimization of physical education assessment index system based on big data analysis. Before getting into the execution, first let us understand what is the project about. So think about how important physical education is. It is not just about running labs or playing games. It is about shaping well-rounded people like students who are not only smart with the books but also physically fit and mentally sharp. Imagine someone who have got all the professional skills in the world, but they get tired just by climbing a flight or by the stairs. Not exactly ideal, right? So now with all the technology that we have around today, smartphones, apps, internet, it is crazy that how much education has changed. But when it comes to physical education assessment, a lot of systems are still stuck in the past. Like they use old school methods that take forever to give feedback. Imagine waiting weeks to find out how you did in simple physical test. Plus, these systems struggle when there is a lot of data. If you've got a bunch of students and load of performance metrics, the system can get overwhelmed. And the thing is, without quick feedback or clear insights, students don't really know where they stand or how they can improve. So that's why there is need to rethink these assessment methods and make them more efficient and accurate and also modern. So, here what's going on is when we talk about physical education performance, the big challenge is that we don't have a solid system to track and analyze how students are doing. Right now, most of the methods used are kind of outdated, and because of that, teachers can't give feedback quickly or accurately. Imagine a student practicing hard for months but only getting feedback when it is too late to actually improve. That's frustrating, right? So now, using big data analytics here, like giving teachers a superpower. So instead of relying on guesswork or delayed assessments, the system can go through tons of performance of the data, past and present, to predict how a student might perform. So if a student consistently struggling with endurance or flexibility, the system can flag that early on, giving teachers the heads up to step in and also help. But it is not easy as it sounds. First, we need to clean the data because not all of it will be useful or accurate. Then we need to figure out which factors actually important for which impact the performance the most. And finally, the models are used to make the predictions need to be optimized so they don't end up giving results that make nonsense. And if we get all that right, through the whole process becomes smoother. So students get timely feedback, teacher can make better decisions, and physical education assessments become less of a guessing game and more of a reliable tool for improving the performance. So, what are we doing in this project is we are incorporating big data technology and also some machine learning models. And by using them, we will be predicting the students' physical education grades. And that grades are AA, BA, BB, CC, CB, and DD, and also failed. So, these are the grades that we will be predicting of the students. And here is the steps that we have followed. So, the system uses Hadoop and Spark to handle the extensive student performance data set. Hadoop, it is distributed file system that is called as HDFS, stores the data across multiple nodes, ensuring scalability and reliability. Spark, with its in memory processing capabilities, accelerates the data processing through parallel execution, which significantly reduces computational overhead when we are dealing with the high dimensional data. Then comes the next step, that is deep learning model. So here a back propagation neural network that is called BPNN. It is employed to learn complex patterns in the student performance data, and the model adjusts connection weights through gradient descent to minimize prediction errors. And the activation functions like ReLU and sigmoid help to capture nonlinear relationships, while the optimization algorithm that is ADAM ensures efficient learning. And BPNN's output provides optimized feature representations for the next stage. Then comes feature selection. So here the system applies a genetic algorithm, that is GA, to select the most relevant features from the dataset. And GA simulates evolutionary principles by iterating through process like selection, crossover, and mutation. The fitness functions evaluates the feature subsets based on performance metrics, discarding irrelevant attributes and reducing model complexity without compromising accuracy. And then the decision tree algorithm is utilized to predict student performance, I mean physical education grades. It constructs a tree like structure where nodes represent features, branches represent decision tools, and leaves indicate grade outcomes. And the model uses information gain or Gini impurity to determine optimal splits and applies running techniques to prevent overfitting and ensuring generalizability to new data. And then we evaluate all the models that are built using accuracy, precision, recall, and FN score. Accuracy, it measures the proportion of correctly predicted grades, and precision assesses the correctness of the positive predictions. Recall, it evaluates the model's ability to identify all relevant instances. And FN score balances the precision and recall to provide a single performance measure. So, by combining the big data network, that is big data framework, with the deep learning model and feature selection techniques, the system achieves high predictive accuracy and supports data driven decisions in physical education performance analysis. So, this is the proposed system part. Now, moving on to the extension. To further improve the performance of this project, we are incorporating CAD Boost model. So, why CAD Boost? Well, it is really good at handling complex data sets and ending up giving us even better accuracy compared to the original algorithms that we have used. But accuracy alone isn't enough. We have also used SHAP. So SHAP basically shows us features, which features had the most influence on the predictions. For example, if student sports participation frequency plays a big role in predicting their grade, SHAP will highlight that for us. And here, to make everything accessible and user friendly, we have developed a simple front end interface using Flask framework. This interface isn't just for testing predictions, it also includes user authentication to ensure the secure access. So, this is the extension part. And to implement this project, we have followed steps mentioned in the flow of work. So, let's understand each of them. How will they be used in this project? So, here, first we have imported all the required libraries like Pandas, NumPy, Scikit-learn, PySpark, and SHAP. So here, Pandas and NumPy for data processing, Scikit-learn for machine learning, PySpark for big data, and SHAP for explainability. Then comes initialization of Spark session. So here, Spark session is initialized using Hadoop HDFS, enabling distributed data storage and parallel processing for large data sets. Then comes loading the data set. So here, student performance data set is loaded into the Pandas data frame. This data set contains information about students' physical activities, skills, and corresponding grades. Then comes data pre-processing. So here, missing values are filled with zero to avoid errors during training, and categorical features are converted into numerical using label encoder technique. And irrelevant columns are removed to streamline the analysis. And all the features are normalized using min-max scaler to bring them into the same range. Then we split the data into train and test, where 80% of the data is assigned for training and remaining 20% for testing. So training is used to train the model and testing set is used to evaluate the model. Then comes feature extraction. So here a back propagation neural network, that is BPNN, is applied to the data set to extract optimized feature representations. And then comes genetic algorithm. So here the genetic algorithm is then used to select the most relevant features for the prediction task. Coming to building the model, so here a decision tree model is constructed to learn from the selected features and all the other models that we built. Then the decision tree algorithm and all the remaining algorithms is trained using the selected features. During training, performance metrics like accuracy, precision, recall, and FN score are calculated. So they are evaluated. Then comes explainability of the features with using SHAP, that is SHAP, which is called as Shapley additive explanations. So SHAP models are applied to interpret the model's predictions. And graphs illustrate which features had the most influence on the prediction. And a web interface is developed using Flask framework. User authentication, including registration and login functionality, is implemented with SQLite database. And then comes user gives input in the feature values. So here in the step, users, they will be able to provide feature values in the front end that will be pre-processed at the back end. It will be fed to the train model. Finally, grade will be displayed to the front end of the application. So this is how we have implemented the project. Now moving on to the algorithms used. So these are the algorithms used. This is the proposed model and this is the extension model. And to implement this project, we need hardware and software requirements. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And the software requirements are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So let's open the code folder. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So in this folder, we have the data set. So let's open it. So this is a data set that is used to train the models for predicting the performance of the student. on the physical education. So these are the attributes. Based on that, we will be predicting this grade. So grade is the target class, that is the class label that we will be predicting. And these are the attributes based on which we will be predicting. So here we have student ID, student age, gender of the student, whether he is of high school or any other thing. And here we have whether how much percentage of scholarship the student gets. Here we have additional work. Here we have sports activity. And here we have transportation, that whether it is private, bus, or public. And then here we have weekly study hours, and here we have attendance status, reading hours, notes, listening into the class, and then we have project project work. So these are the attributes based on which we will be predicting the student's physical education grade. So let's close this. And here in the test data file, we have the sample test cases that we will be using in the front end. So these are the test cases. So here we have total 13 test cases that we will be giving as the input. So let's close this. Let's get back. And here in the model folder, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files. They will be loaded into the project code during runtime of the application. And here in the static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here in this templates folder, we have files containing HTML pages that is used in the project. They are typically include index.html, about.html, etc., which represent different pages of the website. And this is the main.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows us to write and execute code in individual cells, making it a popular choice for the data science. And this is the Windows batch file. So instead of executing this project through command line interface, we have created this run.bat file. So we need to double click on it to execute. Here you can observe, right, main.py file is compiled. So now Flask framework will host the application at the default address, which is the local host and the port unless configured differently. And this command python space app.py which we have given, it will execute the Python script and perform runtime check for any syntax errors or logical issues. And here Flask framework has hosted the application. So this is the address where application is hosted. This is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I have copied it. Now get back to the, I mean, you can paste it in any web browser. So I will paste it in Google Chrome because I prefer that. Paste the link here. At the end, type index and now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So here you can see admin login link, right? So click on that. And here we need to give our username and the password to login as admin. Now click on login. And here we are redirected to prediction page. So here you can see a link, right? That is predict student physical education. Click on that. And here you can see a choose file button. We need to click on that for uploading the test data. So click on that. Open the data set, select the test data, and now click on open. You can see it is loaded. Now click on submit. So this given information, it will be pre-processed at the backend and then it will be fed to the train model. Then train model will be giving us the prediction. So here we got the prediction for all the inputs that we have given. So the first case that we have given, so these are the input. I mean, for the first case, these are the parameters that we have given. So based on the given parameters, it has been predicted as CC, which means that it is average performance. And then here we have for the second case, it has been predicted as fail. That means he did not meet the minimum performance. I mean, he did not meet the minimum performance criteria. And then for this case here, we got the prediction that BA, it is very good performance. And then for this case here, we got prediction as AA, which is excellent performance. That is the highest grade. And for this case here, also we got BA, that is very good performance. And for this case, we got BB. BB is good performance. And then for this case, here we got the prediction as AA, which is excellent and the highest grade. And for this case also we got the prediction that AA, which is the highest one, and this is the third case. That means it is just the good performance. And for this case here, we got the prediction as DD, which is pass with minimal performance. And here we have the prediction as DD, it is also the same. And for this case here, we got the prediction as CV, it is above average performance. And here for this case, we got that fail. So in this way, we can predict the physical education index. So now click on logout. In this way, just by giving input to the application, all the required parameters to the application, then the application will pre-process that. It will be fed with the train model. Then train model will be giving us the grade of that particular student of that particular case. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.